At the edge where forest meets mountain, a single spark can change everything. A calm morning can turn to chaos in moments. This is the story of how one wildfire, born from a dry wind and brittle earth, rose to life at the tree line. From smoke on the horizon to flames stretching for miles, Inferno at the tree line explores the science, the response, and the lasting impact of nature's most powerful combustion event. Wildfires are a natural part of many ecosystems. They help clear dead vegetation, recycle nutrients, and open space for new growth. But in recent years, the frequency and intensity of wildfires have changed. Rising global temperatures, prolonged droughts, and shifting weather patterns have created the perfect conditions for more severe fire seasons. At the boundary where trees thin and mountains rise, the tree line, these fires can spread rapidly. The combination of wind, slope, and dry vegetation fuels a phenomenon that firefighters call the perfect storm. Flames move uphill faster, and hot air currents pull oxygen through canyons, feeding the blaze like a living engine. This particular event began on a quiet afternoon. Temperatures were higher than normal for the season. Humidity was low. A strong gust from the southwest carried dust across the valley. Somewhere along a remote dirt road, a fallen power line sparked against dry grass. Within minutes, the fire began to spread. The first call to emergency services came at 1:47 p.m. By 2, smoke was visible from nearby towns. By 3 o'clock, it had reached the tree line, a zone of pine and fir trees that separates grassland from alpine rock. Here, the fire found its fuel. When flames reach dense forest, they behave differently. At the tree line, the air is thinner, but winds are stronger. Fires don't just crawl along the ground, they climb. Scientists call this vertical spread. Needle-filled trees like pines and spruces contain oils that ignite easily. As one tree catches fire, it releases heat and embers into the air, carrying sparks across hundreds of meters. This process, known as spotting, allows a single fire to multiply across large areas in a short time. By nightfall, the fire covered more than 4,000 acres. Firefighters worked to contain it from the valley floor, but terrain made access difficult. Helicopters dropped water and fire retardant from above. Ground crews dug fire breaks, cleared strips of land meant to stop the flames from spreading. But nature had other plans. A wind shift at 9 p.m. sent embers over containment lines. Flames surged toward the next ridge, burning both live trees and decades of dry underbrush. Infrared sensors on aircraft showed flame temperatures exceeding 1,200 degrees Celsius, hot enough to melt aluminum. Even rocks began to crack from thermal stress. In nearby communities, residents were ordered to evacuate. Emergency shelters opened in schools and town halls. Local officials coordinated through the Incident Command System, ICS, a standardized approach used in the United States and many other countries to manage disaster response. For firefighters, the biggest challenge wasn't just the flames, it was the unpredictability. At higher elevations, air currents shift quickly. A sudden downdraft can push flames sideways or even back downhill. Visibility drops as smoke thickens, making navigation dangerous. By the second day, satellite imagery showed a massive smoke plume stretching more than 100 kilometers across the sky. Ash fell on towns miles away. Wildlife fled the area, deer, foxes, and birds searching for safe ground. And yet within the chaos, there was coordination. More than 500 personnel from regional fire departments worked in rotating shifts. Bulldozers cleared new containment lines, while water tenders resupplied trucks deep in the forest. Air tankers, each carrying thousands of liters of retardant, made dozens of precision drops. By the third day, the weather began to turn. Cloud cover increased and winds eased slightly. A light rain fell over the burned ridges, a brief but crucial moment of relief. Each wildfire tells two stories, one of destruction and one of renewal. At the tree line, that balance is more delicate than anywhere else. These are transitional ecosystems where life changes with altitude. Species here are adapted to cooler temperatures and thinner air. When fire sweeps through, recovery can take decades. So why does it matter? Because what happens at the tree line affects everything below it. The burned soil can no longer absorb rain, leading to erosion, flash floods. Streams fill with ash and sediment, altering water quality for both animals and people. The loss of vegetation also means less carbon absorption, adding to global greenhouse gas buildup. Scientists studying this fire have learned valuable lessons. Data collected from drones and ground sensors revealed how quickly heat can climb slopes and how vegetation density influences fire speed. That knowledge helps improve early warning systems and future prevention. But it also reminds us that many of these fires start with small, preventable sparks. Faulty equipment, unattended campfires, or illegal burning. The cost of one moment of carelessness can ripple across ecosystems and generations. At the same time, controlled or prescribed burns remain a vital tool. When done safely, they remove excess fuel and reduce the intensity of future wildfires. The goal is not to eliminate fire from nature, but to coexist with it responsibly. As dawn breaks over the blackened ridge, smoke still drifts between the charred trees. The ground is silent, but life is already returning. Tiny shoots of green emerge from the ash. A woodpecker lands on a burned trunk, searching for insects. This is how the forest heals, slowly but surely. From the ashes of one fire, a new ecosystem begins to form. And at the tree line, where earth meets sky, nature continues its timeless cycle of renewal. The Inferno has passed, but its story remains. A reminder that fire, though destructive, is also a part of life on a living planet. The challenge for humanity is to understand that balance and protect it. This has been Inferno at the Tree Line. For more documentary-style explorations of Earth's natural forces, subscribe and stay tuned.